Hello class! The lesson that we will be discussing for this tutorial video is the Module 6 for Pre-Calculus, which is the definition of ellipse. So how do we define ellipse? An ellipse is the set of all points in the plane, the sum of whose distances from two fixed points, called foci, is constant. Let us consider this figure. In this figure, f sub 1 and f sub 2 are called the foci, and the midpoint C of the line segment joining the foci is called the center of the ellipse. P and Q are any 2 points on the ellipse. So by the definition, we can say that PF sub 1, the line segment PF sub 1 plus line segment PF sub 2 is equal to QF sub 1, the line segment sub 1 plus line segment QF sub 2. In this parent graph of an ellipse, it's centered at the origin, 0, 0. An ellipse has two axes of symmetry. So in this case, we have the x-axis and the y-axis. Notice that the ellipse intersects each axis of symmetry 2 times. So the longer line segment AD, which contains the foci, is called the major axis. So line segment AD is called the major axis. The smaller segment BE is called the minor axis. Line segment BE is called the minor axis. And the endpoints of each axis are the vertices of the ellipse. For the endpoints of the major axis, points A and D, these are what we call the vertices. The vertices of an ellipse, while the endpoints of the minor axis, B and E, are called co-vertices. Co-vertices. And of course, f sub 1 and f sub 2 are the foci, plural of focus, of the ellipse. So these are the foci. The center separates each axis into 2 congruent parts, congruent segments. Suppose we let A represent the length of the semi-major axis CA. So let's have this one as A. And we also let B be the length of the semi-minor or semi-minor axis BC. Let's have this as B. The foci are located along the major axis, that's C units from the center. So let's have this C from the center to this point is C. Okay, small letter C. So if you notice, there is a relationship, a special relationship among the values of A, B, and C. Suppose we draw line segment BF sub 1 and BF sub 2. Okay, bear with me for a while. and BF sub 2. Now guys, what can you say about this line segments? Okay, correct. The length of this line segments are equal. Why do you think? Why do you think? Okay, obviously these two triangles are congruent, right? So we can say that triangle BF sub 1 C is congruent to triangle BF sub 2 C. So since B and A are 2 points on the ellipse, we can actually use the definition of an ellipse to find for the length of BF sub 2. Again, since A and B are 2 points on the ellipse, we can use the definition of an ellipse to find the length of line segment BF sub 2. So by the definition of an ellipse, we can say that BF sub 1 plus BF sub 2 is equal to line segment AF sub 1 plus AF sub 2. Again, that's by the definition of ellipse. Then, if you're going to look at AF sub 2, that's equal to line segment DF sub 1. So we can substitute this one with DF sub 1 and have BF sub 1 plus BF sub 2 is equal to AF sub 1 plus DF sub 1. So that's because AF sub 2 is equal to DF sub 1. Next, AF sub 1 plus DF sub 1 is equal to line segment AD. BF sub 1 plus BF sub 2 is equal to AD. That's by segment addition. That's AF sub 1 plus DF sub 1 is equal to line segment AD. Then, a while ago, we discussed that the length of the semi-major axis is A. So, from this center of the circle to one of the vertices of the ellipse, the length is A. So, if this is A, this is also A. The length, therefore, of line segment AD in terms of A is 2A. That's correct. So, it's 2A. So you have BF sub 1 plus a BF sub 2 is equal to 2A. We just substituted by substitution. That's AD is equal to 2A. Then, since we're looking for the length of BF sub 2, and since these two line segments are equal, we can substitute BF sub 1 with BF sub 2. So we'll have BF sub 2 plus BF sub 2 is equal to 2A. Thus, you'll have this equal to 2 BF sub 2 is equal to 2A. Because BF sub 1 is equal to BF sub 2. We can now simplify. Divide everything by 2. Therefore, the length of the line segment BF sub 2 is equal to A. So, therefore, this is A. This is C. And this is B. This line segment is B, this one is C, this one is A. Since BF sub 2 is equal to A, and triangle BCF sub 2 is obviously a right triangle, therefore, what conclusion can we draw from here? Therefore, B squared plus C squared is equal to A squared by the Pythagorean theorem. Do not get confused, guys, on the original formula for Pythagorean theorem, which is C squared is equal to A squared plus B squared. In this case, for ellipse, since A is the longest, we denote A as the longest side, so we will have this formula, okay? B squared plus C squared equals A squared. Or if we're going to look for a B squared, then it is equal to A squared minus C squared. If you're going to solve for C squared, then that is equal to A squared minus B squared. Okay? Please take note of this. Thank you.